right, we're back for the next Make It and Take It science experiment. This one is called the Cartesian Diver. For this experiment, you're going to need one of your bottles from your fountain connection, or if you have a different one that you want to use, that's fine. This is a 1 liter bottle, and you're going to need to get a glass and fill it with water. A tall glass works really well. And for this experiment, we're going to need a pipette and a hex nut, pair of scissors. So to start out, we're going to be making a Cartesian diver today. It's a classic experiment named after René Descartes. Hopefully I said that right. He lived from 1596 to 1650, and he was a French scientist and a philosopher who invented coordinate geometry and made great contributions to the philosophy of science. So Descartes studied about floating and sinking and why things float and why things sink. And that's what we're going to do here today. You're going to take your pipette and your hex nut. You're going to push it all the way onto it like this, and you're going to twist it kind of like that so that it doesn't come off. Now you're going to snip the end off like this. Now in your glass of water, we're going to be squeezing a little bit of water into the pipette. Let me try that again. It kind of slipped off there. And again, to make it stay on, you should twist it a little bit. There it goes. All right, so now I'm going to squeeze just a little bit of water into our pipette and let go. And you can see it floats in there. Why does it float? In the pipette, you'll see air. And the air is what's causing it to float. If I squeeze more water into it, now I'm going to squeeze a whole bunch of water into it, what will happen then? Uh-oh, it sunk. So that's what will happen to it. So if it has too much water in it, it will sink. Okay? If we squeeze a little bit of that water out, it will float. And that's the whole principle of how it works. And that's also the principle of how a submarine works. So now I squeeze a little bit of water out of it, and it floats again. Okay? So now we're going to bring out the bottle. And the reason you try it in the glass first is simply because you don't want it to sink in your bottle, and then you'll have to dump all the water out of your bottle, make a big mess. So I have the pipette with some water in it. It's a little bit less than halfway full. And now I'm going to put it into the bottle. And I'm going to put the cap on the bottle. And I'll hold that up so you can see it very well. Bottle is sealed tightly. Screwed the cap on all the way. So you can see it there floating at the top. Uh-oh, wait a second, what happened? Oh, it sunk, but then it rose back up. It's sinking and it's rising. Why is it doing that? Well, if you watch my hand, you'll probably see that I'm putting pressure on the bottle. When you squeeze the bottle, it causes an increase in pressure. And what that does is it pushes the air out of the pipette, and more water is let in the pipette. So we squeeze the bottle, and you can actually see the water level change in the pipette. The air gets compressed, and then more water is in the pipette, and that causes it to sink. And that changes by the amount of pressure that you apply to it. And that's how it works. All All right, we're back, and this next variation of the Cartesian Diver is going to be a lot of fun. We have 3 different divers, and each one I'm going to squeeze a little bit more water into, or a different level of water into it. So our first one is about half full, and it just barely floats, just barely. So I'm going to put that into the bottle. Our next one's going to have a little bit less water. And our last one, very little water. So we now have 3 in the same bottle. And we're going to seal that up. And so what will happen here? So you can see them all at the top there. And when we squeeze the bottle, right away one of them goes down. That's the one with a lot of water in it. Then we have to squeeze a little bit harder to get the next one to go down. And then the third one needs tons of pressure, 2 hands. I cannot get it to go down. So this is the Cartesian strength tester. Okay, also more popularly known as the counting Cartesian divers. And it works by changing the amount of water in each of the pipette. So as you squeeze, it changes the pressure inside the pipette, causing it to sink. Okay, the more water that's in there to begin with, the harder or the easier it is to make it go down, and the less water, well, the less water, I got that one to go. Okay, so that's experiment 2 with your Cartesian divers. All right, we're back again for another experiment with Cartesian divers. And for this one, I just want to go over a few details with Cartesian divers. You're going to constantly need to keep filling your bottle, making sure that it's full all the way up to the top. Sometimes it helps to do this experiment near the kitchen sink or in the kitchen sink. And that way, you know, your mom will be happy with you that you're not making a huge mess all over the table. Our next one is called the hook diver or the rescue diver. And to do this, you're going to need a couple pieces of wire, which are also in your little baggie. And you'll need 2 divers. Okay, so here we go. Our first diver, we only want to put a little bit of water into it. Okay, so way less than halfway. Okay, about that much. And what I'm going to do is I'm going to wrap the wire around the top, and I'm going to make a hook. So we're kind of making like a density science game here. Okay, so I have the diver with a little hook on it. And I'm going to put that in the glass, make sure it works. And if it does, terrific. You can put it in the bottle. And I'm just going to put the cap on the bottle so we don't have an accident. And our next diver, we're going to make a loop. I'm going to make some sort of loop either over the top of the diver or underneath it. Depends really how hard of a game you want to play here. But I'm going to, I'll put it like the opposite way, kind of like that. And then I'm going to make this one so that it just barely sinks in my cup. You can see it's sunk to the bottom, kind of. It's almost sunken. Okay, so then we're going to put it in the bottle like that. Okay, so I'm going to get that out. Opening my bottle. And I'm sinking that in. And it should sink. There it goes. So in the bottle, you can see it's down there. The hook is down there somewhere, facing up, and then you have your other one facing down. Now the object of the game is to rescue the diver. So you're going to make the blue hook diver come down and rescue the red one. And not as easy as it seems. And try to pull it all the way to the top. So you have to kind of like work it around in there and get it to go down and hook. Oh, that one was close. You're going to try to get it to hook your other diver. Here it comes. Well, I'm going to let you try that. Try to rescue your diver with it. Okay, I'm going to stop the video and you can try to make the hook and diver game. Alright, so now we're going to make another variation of the Cartesian diver. This one is called the sealed diver. To make this one, what you need is your regular Cartesian diver that you used maybe from one of the other experiments. And we're going to be placing just enough water into the diver so that it floats or barely floats. Okay, let me just put a little bit more in there. So it is floating right now. Now I'm going to turn it upside down like this. I'm going to dry off this end real good with some paper towels. Always good to have on hand if you're doing this experiment, or a cloth towel. And now what we're going to do is we're going to seal it up. That's why it's called a sealed diver. And I'm sealing it with hot glue. I'm going to hold it like this until that glue dries. Try not to squeeze it because you'll get little air holes in there. And after about 10 seconds or so, it dries up pretty good. And now, will the diver work? Let's go over again how it works. When you squeeze your bottle, you add pressure. That pressure pushes more water into your pipette and compresses the amount of air in there. When you let go, that air which was compressed then pushes back and pushes that water back out of it. But now, no water is going to be able to go into the pipette other than the water that's already in there. So what's going to happen now? Let's find out. So this works because of density. We have two things at play. There's a volume of air in there, and there is a certain mass that it needs to make it go down. So let's take a look at it now. Can you see that in the video? I'm hoping so. And now, when I squeeze, wait a second, how did that sink? Oh, well, let's watch. If you see it closely, you can see that the pipette is being crushed. It's the pressure, it is not pushing water up into it and compressing the air in there, but instead it's being compressed on the sides. Okay, and that's causing the amount of air in there to become less because you are squeezing it and it is squeezing the pipette. So pressure causes it to go down. And that is called a sealed Cartesian diver. Hope you enjoyed experimenting with Cartesian divers. See if you can come up with some of your own experiments.